my name is Cassie Feldman, and today we are going to be doing an experiment called Water Bottle Balloon Inflator. These are the students, Emma and Easton. They're going to be conducting the experiment with me today. First, I'm going to go over the expectations of the students of the class. Number one, wait for and follow directions, okay? Means don't jump ahead of us and go ahead and start doing things because there's a process to the experiment. Number two, be responsible in handling the materials. We don't know what this stuff is that we're using, and it could cause an explosion. You never know. So you got to be responsible. Number three, work together and be respectful. Okay? Got it. All right. We're going to go over the 7 steps of the scientific method while we are doing our experiment. Number one is, the first step of the science experiment is state the problem. So our problem today is, does the amount of baking soda affect the amount the balloon inflates? Emma's showing the balloon here. Go ahead and set it down. All right, the second step of the scientific method, gather information. So we're going to talk about our materials we're using here today. So I want to ask, do you all know what baking soda is? Baking soda, have you ever heard of it? Emma, what's baking soda?
Baking soda is this powder right here, and it's white.
It is powder, yes it is. Do you know what you might use baking soda for? What would you use baking soda for?
Sometimes when you're like making a food.
Yeah, for cooking? For baking? What do you think, Easton? You think the same thing? You use baking soda for cooking? Yeah, and baking? Okay. Have you all ever used baking soda with anything? Have you? Today we're going to use it. You're right. We are going to use baking soda today. Okay, buddy. So yes, today we're going to do an experiment with balloons, water bottles, and baking soda to observe whether the amount of baking soda affects the results. All right, step 3, develop a hypothesis. You all ever heard of a hypothesis? Not sure?
I have, but
you haven't had science?
I don't remember the meaning.
Okay, well, a hypothesis is an educated guess. So we are going to, our hypothesis is going to be, do you predict the amount of the balloon inflating will change if we use more baking soda?
That's my job.
So what is your hypothesis? Do you think that the balloon will inflate more if we add more baking soda, or do you think it'll stay the same? Yes, Emma. What is your hypothesis?
Maybe when we like flip the bottle over with the balloon in it, it'll pop.
You think the balloon's going to pop when it inflates too big?
Mm-hmm.
Do you have a hypothesis, buddy? Do you think the balloon will get bigger if we put more baking soda in? Do you think so? All right, we're going to test that today. All right, for our experiment, we are using 2 empty water bottles and 2 balloons, and we are also using vinegar, baking soda, and you will need a funnel or a piece of paper to use as a funnel, and a measuring tape, or you can use a yarn and a ruler. Okay, so we are in our group of 2 here. And I have pre-discussed what a controlled variable is with the students, so we'll go over it again. A variable is anything that's used in the experiment. Your controlled variable will be the variable that stays constant. And let's see here. So our controlled in this instance is going to be the amount of vinegar. So for you all, what is the variable that we are testing? Since the vinegar is the controlled and it stays the same, which one are we going to test? The amount of baking soda in the balloon? Yes, you're right. Good job. And what other variables might be controlled in this experiment? Since the baking soda is is the only one that changes. What else is the same? Yes, Emma. You have a guess? Any idea what else is the same between the two? Yes, buddy. What do you think?
Instead of a balloon like this, a balloon that's not rubber.
Well, that would be a different. That would be a regular variable, not a controlled variable. So our controlled variables in this situation are going to be the two water bottles. They're the same size. They're the same material, and that. And the balloons. The balloons are the same size and same material. So they are exactly the same, just a different color. That shouldn't make a difference in the experiment. Okay, let's go ahead and get started. First, we are going to pour vinegar, a half a cup of vinegar, into each bottle. We need to make sure we pour exactly a half a cup for each. So here, do you want to pour it to the half line, or do you want to pour it into the bottle? You are supposed to. Here, you go ahead and do it. I am supposed to watch you do it. Yes. Pour it until I tell you to stop. All right, slow down, slow down. Oh, okay, perfect. No. That's perfect. Thank you. Okay.
There's
Now.
a millimeter more.
That's okay. It's
a millimeter.
It's right at a half.
And
Now, I'm going to help you. So we're going to pour.
Vinegar.
Do you? All right, hold the cup there, and we are going to pour it very slowly into the bottle. There we go. We're going to pour all half a cup of vinegar into our water bottle.
I was kidding.
And okay, that is all of it. So make sure you don't knock that over. All right, bud. Now we are going to do another half a cup into your water bottle. Emma, please put it down. Did I say be responsible with the materials and wait for and follow directions? Thank you. Okay, here, you pour a half a cup. Go ahead and pour it in, and I will tell you when to stop.
So when it gets to the 1 and 2?
We'll get to the 1 and the 2, yes. That is 1 over 2. That is 1 half. Keep going. Almost there. Okay, whoa. No. That's perfect. Okay, that's good. Thanks, buddy. Okay, now we're going to pour yours into your water bottle as well. Do you want to hold that? And I will try to help you. We're going to pour it real slow so we don't spill any, okay? And pour it all in. Good job. Come on, pour the rest. There we go. Okay, make sure that's all. Good. Okay, we're going to set that aside because we don't need the measuring cup any longer. I went ahead and pre-filled the balloons with baking soda because it was actually pretty hard to get the baking soda into the balloon. So with this one, we only filled it 1/8 of the way. I marked the balloons 1/8 of the way with baking soda. So it only has the tip with baking soda, just a little bit. We didn't want too much because we didn't know how big the balloon would get. And with the yellow balloon, we filled it about 1/4 of the way. So it is down about here, and it's actually twice as much as what is in the green balloon. All right, guys. Now we are going to put the balloons around the neck of the water bottle. And see if you want to try it, but we're going to make sure we get it over top. So you can do it there, Emma. Make sure you get it all the way over the top of the water bottle. Nope, it needs to be all the way over. Take it off and try it again. Leave it there. Take it off and try it again.
And then
You're going to tear the tip of the balloon. Please don't tear it. There we go. Try it one more time. So you got to stretch it all the way over the top. Now make sure that none of the baking soda gets out of the bottle. Break it. Make sure it goes all the way down over that side. Almost got it. Let me help you. It's just I want to make sure we don't spill any. Okay, there we go. Because we want everything to be the same. We've got to have everything controlled. So we make sure we do it right. Okay, so we got our hypothesis. We're not turning it over. We are not turning it over. Please wait for directions. All right. So we have everything ready for our experiment. And remember our hypothesis. We believe that the balloon will get larger with more baking soda, correct? Okay. So when you all are ready, I want you both to take the balloon, just the balloon, the water balloon, or water bottle is going to stay. And we're going to lift the balloons up and see if our hypothesis is correct. So when you are ready, 1, 2, 3, go ahead and lift them up. Dump all that baking soda into the bottle. And then just let it go. Oh, no. Leave it sitting still, please, Emma. Oh, goodness. Are we going to explode? What do you think is going to happen? No, come back here. Sit down, please.
Hopefully mine pulls up all the way.
All right. So I believe that's it. The baking soda and vinegar is starting to settle. So now, Emma, please, that is not in the directions. Do not touch them. What our next step is to measure the balloons. We can obviously tell which one is larger. We're going to go ahead and complete our experiment. We are going to measure each balloon using our measuring tape here and find out which one is larger and record data on the measurements.
Which one? Inches or centimeters?
We're going to use inches and go ahead and go around
the balloon.
The biggest part of the balloon. And we want to see how big it went. Let's see here. This one is almost just about 16 and a half inches. 16 and a half. Let me get a pen.
It's okay.
We have for balloon A with the, I'm sorry, but this one's balloon B. We have 16 and a half. Okay. Now we are going to do, you want to measure the small one? You want to help?
I want to do
so you're upset because you're sitting real larger?
Do it again.
The next one here, it is about 10 and a half inches.
Do it again. Put more baking soda.
So,
yeah, do that.
What did you observe as you poured the baking soda into the vinegar? What did you all see? Once the baking soda started falling down, what was happening? What happened down here?
It was like rising.
It started to bubble and rise up. Yeah, it did. It went up into the balloon.
Well,
what did you see, buddy? See, like it's still doing it a little bit. There must be some more baking soda in there. What do you think happens? Is that a chemical reaction?
What's my balloon doing?
The water.
Oh no, it's coming out!
From the vinegar and the baking soda, it's reacting, isn't it? And that's what caused it to fizz up and foam up the balloon, huh?
My balloon was coming, the water.
Another question here. What did you observe about the balloon that had more baking soda? What happened? What happened to the balloon with more baking soda?
It rised a little bit more, as you can see.
It did. It got larger, didn't it? It inflated more. So was our hypothesis correct?
Yeah.
Yes. With the more baking soda is going to create a larger reaction. Therefore, the balloon is larger.
A ton of baking soda.
Okay, so we came to conclusion. That was the next step in our scientific method. That the balloon with the more baking soda has inflated more.
And put more in.
Now, we're going to apply the results to a real-life situation, a real-life application. So we discussed that you can use baking soda when cooking, Emma suggested. Have you ever used baking soda when cooking?
No.
No? I don't think I've done it either.
You can make one?
You can. What would you use when you were cooking if you were using baking soda? Yes, Emma.
You could use...
What would you be making?
I heard that they make their burgers out of like that.
I don't know baking soda.
It's not fresh meat.
What would you bake with baking soda? Emma.
I don't really know.
What would you bake with baking soda? Could you make a cake with baking soda? Anything with baking soda to make it? What would it do? Why would you use baking soda? If the balloon rises and expands, what do you think would happen to a cake if we used baking soda? Yes, Easton.
The icing would shoot off.
No, the cake would rise. The cake would expand. You ever made brownies or a cake and it's just a little bit in the pan, and then after you bake it, it got bigger?
Yeah.
You ever seen that? Yeah. So that is our experiment for the water bottle balloon inflator. And we have come to the conclusion that our hypothesis was correct. And more baking soda creates a larger balloon effect. Thank you.